All right, here we go. We're going to look at these two soccer players. We'll look at this problem. Two soccer players start from rest. They're 48 meters apart. They run directly towards each other. They should have told me they were starting from zero. Okay, so they start from zero. The first player's acceleration has a magnitude of 0.5. So he's a little, he's got a bigger bolt of energy, 0.5 meters per second squared. The second player's acceleration has a magnitude of 0.3 meters per second squared. These are accelerations. These aren't speeds. How much time passes before the players collide? At the instant they collide, how far has the first player run? Well, let's analyze this part. So 48.5.3. All right, let's analyze this. Then we'll talk about free fall and we'll be done with this thing. Okay, and we'll do some free fall in class just to get you ready for it. Oh, I gotta make this a little bit smaller. So here we go. All right, so let's draw what we have here. This is 48 meters. Okay, here's soccer player 1. And he's running a little ball here, a little soccer ball. All right, this way. 0.5 meters per second squared. 0.50. The other soccer player is running the other way. Okay. All right. Now then, they're going to meet somewhere here. So that distance from this soccer player is x, and that distance, this distance from this soccer player is 48 minus x. That's kind of the trick to the problem. So you got that little thing, but we do know we have a formula for when we know the distance, and they start for each of their initial velocities are equal to soccer player A is 0, the initial velocity of soccer player B is 0. We have a nice little equation where we know the distance is equal to v naught times t plus 1/2 at squared. We're going to use this formula. Let's look at the first soccer player. Okay, so he's going to go a distance of where this goes to 0. So 48 minus x is equal to 1/2 of 0.5 times t squared. Right away you're going, well, wait a minute. I got two unknowns and only one equation. Let's write another equation. We know that this soccer player is accelerating this way in the negative direction, negative 0.3 meters per second squared. And he's going to be going from this part, well, this is x final, and this is x initial for this guy. He's going from x final minus x, so he's going in a negative x, his displacement is in the negative x direction. So we'll say negative x is equal to 1/2 times negative 0.3 times t squared. Oh, wait, look at that, negative. So those negatives cancel, so I've got x is equal to 1/2 0.3 t squared. Aha! I take this value, stick it in here, and there we go. So we've got 48 minus 1/2 0.3 t squared is equal to 1/2 0.5 t squared. So so I wind up with 48 is equal to, what's half of 0.3? 0.15, right? 0.15 t squared plus, what's 1/2? 0.25 t squared. So I've got 48 is equal to 0.4 t squared. So therefore 48 divided by 0.4 is equal to t squared. Take square root of both sides. Yada, yada, yada. That's 16 times, okay, it's going to be kind of, I could do it almost in my head if I want, because I could say, okay, well, this is 16 times 3, and this is 4 times 0.1. And so I could divide the 16 divided by 4. Let's just do it without a calculator. I'll show you kind of a little. So this is 16 times 3 divided by 4 times 0.1. Like, so we've got divided by 0.1, so we're basically multiplying by 10. All right. So that cancels. And so this will equal 10 times 4 times 3 is equal to t squared. And I can take the square root of that, and I wind up with 2 times the square root of 30 is equal to t. That's the in algebra class, that's the way you solve that. But let me just see what we wind up with here when we've got 48 divided by 0.4. This, take the square root. Oh, look at that, 10 times 4, that's 12, that's 120. Got it. 10.95 seconds. And that makes sense. They're 48 meters apart. They're not running at full speed. So yeah, that makes sense. Let's do one more on this one. And then I'll talk about free fall. And we'll look at the free fall problems in class. All right, when we meet again on Tuesday. Here's a good problem. Right here it is. So I wanted to look at this. Again, airplane, 40, coming in. All right, I hope you can read that. So it says a Boeing 747 has a length of 59.7 meters. The runway on which the plane lands, okay, the runway on which the plane lands intersects with another runway. The width of the intersection is 25 meters. The plane decelerates through the intersection at a point of 5.7 meters per second squared. That will smash you into your seat. I mean, that'll put that seatbelt on. But anyway, and it clears it with a final speed of 45 meters per second. How much time do we have an initial velocity? Boeing 747 has the runway on which the plane lands intersects another 25 meters. The plane decelerates the intersection at a rate of 5.7 meters per second squares and clears it with a final speed of 45 meters per second. How much time is needed for the plane to clear the intersection? Well, I don't know the initial time. Oh, I should have worked this out before I got down there. Okay, I'm going to stop here and I'm going to come back and we're going to look at this. Because I'm going to, and this is a great teaching moment because I'm stuck. Oh, 8 stands for this is a hard problem. This is a hard problem. So I'm trying to figure out if I need to waste your time. Yeah, I'm going to waste your time. You don't have to watch this one. I'll put it as track 4, hard problem. You can skip if you want.